dbt or data build tool is a popular tool in data engineering, and it allows you to model transformations in your data warehouse using SQL files that are augmented with Jinja templating syntax. So we're going to look at a small sample problem in this video and demonstrate how dbt works with a Snowflake database. So this is going to be something a little bit different for the channel, more of a data engineering video. If you want to see more of those, let me know in the comments. And before we get started, if you want to support the channel, check out this Ko-fi page. We've got that pinned in the top comment, and thanks to everyone that's contributed. So if we go back to the documentation, dbt is an industry standard for data transformation. This is a very popular tool for data engineering, and it allows you to transform raw data into analysis-ready insights. And some of the benefits of using dbt are listed here. So it allows your team to prepare data for analysis in a way that's centralized, modular, and entirely open. And that can all be done inside your cloud platform. And you can see it's used by HubSpot, among others, just below here. Now I want to get started by installing dbt-core. And I think the best way to understand what dbt does is just to install it and start using it. So dbt-core is an open source project and we can develop from the command line. What I'm going to do is install that using pip. So if we open up VS Code, I have an empty directory here that contains just a virtual environment in Python. What we're going to do to start with is activate this environment. And once we've done that, we can install dbt-core. So pip install dbt-core, and that's going to install that into this environment. Now once we've done that, let's clear the terminal and go back to the documentation again. Now one thing about dbt is that it uses adapters. So dbt works with a number of different data platforms, for example databases and data warehouses, and any kind of query engine or SQL speaking technology. And it does this by using a dedicated adapter for each one of those platforms. Now some examples of that might be something like Snowflake, or Amazon Redshift, or Postgres, Databricks, and so on. There's quite a lot of these platforms, usually used in data engineering for storing large volumes of data and transforming data as well. dbt has some adapters for most of these. Now I should note before we go on, as well as dbt-core, which is something you can use on the command line, there is also the dbt cloud, and that has additional features such as a browser-based IDE, AI assist tools, and also native job scheduling for your dbt pipelines, as well as a bunch of security and maintenance options. We're not going to cover dbt cloud. That's all built on top of dbt-core anyway, so let's just get started with dbt-core. We're now going to install the adapter to connect to the Snowflake database, and we can see some of the trusted adapters below here, for example Apache Spark, Athena. We have stuff on Azure, BigQuery, Databricks, and so on. There's lots of these, but we're going to use Snowflake, which is a very popular data warehouse tool, and we're going to click Install with dbt-core. Now I have a Snowflake data warehouse available, so you can get the free trial for Snowflake if you want to learn about that and follow along. And if you look at the data directory here on the left hand side, I've used a guide from dbt to load data into this raw database, and we have two schemas of note. One is the 𝗏𝗡 schema, and that has two tables, one for customers and one for orders. And if we look at the data preview here, we can see some of the data that's in those tables. So the customer has an ID, a first name, and a last name. And you can imagine this is raw data. It came from a source. For example, it could be the database behind a web application. And what we want to do with dbt is take the raw data and transform it and store it in this analytics database that we have here. And that transformed data should be useful to the business. It should provide insight into the data itself. Now, if we look at orders and go to the data preview, orders have an ID and also the user ID who placed the order, as well as a date, a status, and we have this ETL loaded at datetime field on the right-hand side. Now, we want to actually tell dbt to connect to this database. But before we can do that, we need to install the dbt Snowflake adapter. So let's grab this pip install command here, and I'm going to bring that into the terminal that we have on VS Code. Now we've already installed dbt-core, but that's just going to install dbt Snowflake as well, and now we can start using that. Now we can initialize a project using the dbt-init command on the terminal. So let's execute that command, and it's going to bring up some options for our project. Now we can give the project a name. I'm just going to call this dbt_demo. Once we've done that, we have the option to set up a profile, and we can select a database based on the adapters that are installed in the environment. So we're going to select Snowflake, and then we need to get the account value here. So in order to do that, I'm going to go to the Snowflake UI, and you can see your account here. What I'm going to do is go to the account details here, and the account identifier, that's what we want to copy here. We can copy that, and I'm going to paste that into the terminal here. We can now set up a dev username, and I'm going to use bugbytes as the username. And let's select password authentication and provide a password. Now for the role, what I'm going to do is select this role here. It's account admin. So we're just going to select that. And what we're doing here is just telling dbt how to connect to the Snowflake database. For the warehouse name, let's give it a name of transforming, and that matches the DBT documentation for this particular example. Then we have the database. This is the default database that DBT is going to build the objects in, and we're going to select the analytics database that we have here. So the idea is to take the data from the raw database in this data warehouse and transform it and store it in this analytics database. So let's select that on the command line now. And I'm going to give the schema a name of dbt_schema. You can call that whatever you'd like. And we'll select one thread. Now that writes a profile to this location here. And the profile contains the details about the target. And the target is essentially the database that you're connecting to in a DBT project. And notice as well, when we ran the dbt-init command, it's created a new directory here called dbt-demo. And that was the name of our project. And one of the directories here is the models directory, and there are some other ones as well. And we also have a dbt-project.yaml file. So this is a key file in a DBT project, and it contains paths to all of the different directories that we have for models, seeds, and so on. Now the models directory is the key one to look at. That's where most of your development with DBT will take place. So models in DBT are simply SQL files. So let's have a look at this one here that's provided in the dbt-init command. And you can see immediately we're using some Jinja syntax here and using a config function. And then we have SQL queries here. So we select some source data and the statement ends just with a simple selection across that source data. Now these models define transformations against source data. For example, you might want to aggregate data and get some insight into large data sets. But you could do simple transformations such as renaming columns and staging models, as we'll see very soon in this video. And your final selection from the DBT model is what's actually going to materialize in the underlying database. Now we're going to materialize these two dummy models in a second, and we're going to work from this data that we've loaded in for customers and orders from the Jaffle shop schema. And if you want to know more about how to get this data into Snowflake, I'll leave a link to this guide below the video. And this will walk you through populating the database with that data, and it will provide sources to that data as well. So we saw that we had a model here, and it's called myfirstdbtmodel.sql. We have a second model as well, and notice this ref function in Jinja. So we're referencing that first model. So what this means is that the second model is downstream from that first model, and the first model is a dependency. So we're referencing the output of that first model here. And by using the ref function, we're essentially building a dependency in this model to that initial model. So this model here is downstream from that first model. And what you're doing by using the ref function is building up a DAG or a lineage of models in your application. And that DAG represents the transformations from some source data to the final output. Now we can run this with the dbt run command. So let's test this out now with dbt run. And that's going to also test out and make sure we can connect to the Snowflake database. Now I have an error here, and that's because I'm not in the correct directory. We need to go into the directory that contains the dbt-project.yaml file, and then we can run dbt run again, and that's going to start this process. Now you can see it's running, it's registered the adapter for Snowflake, and it's found 2 models and 4 data tests and 474 macros, and it started executing that SQL for these models. And you can see the success message here, it's completed successfully. Now what has actually happened with dbt run? Let's go back to Snowflake, and we're going to look at this analytics schema, or database rather, that we have here. And if we refresh this, notice that a new schema is created, and it's the one we created on the command line. It's called dbt schema, and that contains a table called myfirstdbtmodel, and it also contains a database view called 𝗫_dbt_model. So what's happened is that the SQL from these models has been executed, and it's created new entities in that database schema. And the reason the first one is a table is because it's being materialized as a database table. So the final select here, that's going to materialize this query as a table in that database. And that's an amazing thing about DBT. We don't need to worry about writing the create table logic and any kind of data definition language statements. That's all going to be handled for us, and we can just focus on the logic for these transformations. Now by default, DBT is going to materialize your models as database views, and that's why the second one is materialized as a view in Snowflake, as you can see here. You can change that, of course, on a per model basis, and you can also set the strategy for a particular directory. So imagine that you had a staging directory here and you want to materialize those as views. You can actually set that up in your dbt-project.yaml file. Now I want to move on to something a bit more useful here. We've already seen that this raw database in Snowflake that we have here containing the customer and order data. And let's imagine for these orders which have an order date, we want to get the number of orders per month. Now what we're going to do to start with is create what's called a staging model. So let's go to VS Code And I'm just going to delete these two models. We no longer need these in the project. And inside the models directory, let's create a new file here, and we're going to call it staging_orders.sql. Now, staging models in dbt often map one-to-one with source tables in the database. So for example, we have an orders table here. The staging model for the orders table should basically select all of this data, and it can perform light transformations, but nothing too complex. For example, we might want to rename a particular field. So let's take this user ID column. This links to the customers table and the ID column in that. We might want to rename this as customer ID. Now I'm going to paste in some SQL into this staging model. So we're going to create a common table expression here called raw orders. And that's going to be this selection here. So we're selecting the ID and we're performing a rename of that column here. And that's going to be called order ID, and same for this one here called customer ID. We're also selecting the order date and the status columns from this particular raw table. So we create the common table expression, and at the end of the model, we simply select all from that particular expression, and that's our staging model. We can then use this model downstream, and what I'm going to do is create a new file here, and I'm going to call this monthlyorders.sql. So this is the new model, and this is going to refer to the data that's being output from the staging orders model. And again, we're going to use that ref function in order to do that. So let's create a common table expression here. And we're going to call this CTE transformed orders. And that's going to be as the following select statement. And again, I'm going to paste this selection in here. So we're selecting the order ID. And then we're taking the order date column. And we're truncating the values of that column to a monthly interval. And we alias the result as order month, and we also select the status here. And notice again this Jinja expression. This creates that lineage or that dependency from this model to the upstream staging orders model. And we're going to see how that's represented in a graph very soon. Now, once we've created transformed orders, what I'm going to do is paste in a second common table expression called final. And that's going to be a selection over that initial common table expression. And this time we're getting the order month. And that's what we had here that was using the date trunc function. And then for that order month, we're also going to count all the order IDs, and notice that we're grouping by the order month and also ordering by that column. Now the purpose of this is going to be to count up the number of orders per month. So we're grouping by that order month that's created in the initial common table expression. And that's all we need to do here. I'm going to save this, and what I'm going to do is go back to the terminal. Let's clear this out and rerun the dbt run command. And hopefully we're going to see two new models or two new tables created in the underlying Snowflake database. And I've got an error here. We've got an unexpected character, and I think this is happening somewhere in the initial staging model. So I'm going to remove this at the end here, and we can save this again and just make sure we don't have this here. So let's save those and rerun the command. And this time it's completed successfully. So let's go back to Snowflake. And in this dbt schema here, we have the models from our initial run. That was the dummy models from dbt's init command. When we refresh this, we get two new views. One is called monthly orders, and the second one is called staging orders. Now I'm going to go to monthly orders, and let's have a look at what's in this table. So we can go to the data preview, and this is very simple. We have each month here on this column, and we have the total number of orders on the right hand side. So we've taken the data, we've grouped it by the month where the order was created, and then we've counted the number of orders for that month. Now you might want to materialize this as an actual database table and not just a view. In order to do that, it's very simple. We can go back to our model here and go to the top, and we can add that config directive from Jinja and set the materialization strategy to table. So if we rerun this again using the dbt run command at the bottom, once that's completed, we can go back here and we're going to see the monthly orders appearing under the tables now. So let's refresh the schema, and we can now see this is a database table and it's not just a view. Now you can also view documentation on dbt. So let's go back to VS Code. I'm going to clear the terminal here, and dbt has a docs command. So we can generate documentation using dbt docs generate. And once that's generated, we can clear the terminal, and there's another docs command. We can run the serve command, and that's going to bring up a browser with that documentation. Now you can see that that's been loaded here, and we have information about the project here, dbt demo. We can view the models, for example, and we see the monthly orders and the staging model. And this icon at the bottom right allows us to view the lineage for our entire project. So for example, here we have the staging orders model, and we can see this directed graph here pointing to the monthly orders model. dbt knows about this graph because in the model itself, we've used the ref function here to refer to that upstream model. So dbt, when you generate the documentation, can tell you about the dependencies between models. And obviously this is very simple. There's only two models. But this kind of view here will be very useful if you want to target specific models in a larger project. Now let's talk about adding sources to our project. Now notice the ref function here is referring to another model that we have in this project. But if we go to the staging model, which remember is the first model in the DAG, this is referencing a table here, and it's doing that explicitly using the table name and the schema name as well. What we can do instead is add something called a source, and I'm going to go to the dbt documentation. Now sources make it possible to name and describe the data that's already loaded into your warehouse by other extract and load tools. And by declaring these tables as sources in dbt, you get some benefits here, so you can select from them using the source function in Jinja, and that helps define the lineage of your data. You can also test the assumptions about your source data, and there's also options for calculating how fresh that source data is as well. What we need to do is create a new file in the models directory called sources.yaml. So let's go back to VS Code, and we're going to create a new file here. And I'm going to paste the code from this example in. So I'm going to leave a link to this page just below the video. Let's paste in this code here. And what we can do is go up. We've got a sources block here, and we have the name of the source. I'm just going to keep these examples as they are. The database is the raw database, and that should correspond to what we have on Snowflake. So we have this raw database, and it's the 𝗙𝗵𝗽𝗶𝗹 schema. So for the customer source and the order source, that's going to be the schema, and you can see that here. It's called 𝗙𝗵𝗽𝗶𝗹, and the tables are listed as well. So we have the customers table, and we also have some documentation here. For example, the description of that table, and similarly for the orders table. So these two names, we can now refer to these using the source function. Let's go back to staging orders.sql, and we're going to use that function now in a Jinja block. So it's going to be the source function, and the name of the schema was 𝗙𝗵𝗽𝗶𝗹, or rather the name of the source was 𝗙𝗵𝗽𝗶𝗹, and the name of the table here is the orders table. So if we go back to sources.yaml, this name here is what we're referencing as the first parameter, and then the table is this one here. Now we should be able to rerun the dbt run command, and this should still work now that we've replaced that hard-coded reference with the source. And you can see that that completed successfully, so there were no issues there. If we cleared the terminal, I'm going to run the dbt docs generate command again. That's going to generate the documentation, and we're going to see something important when we serve this documentation. We are now able to view this source as part of the lineage for our DAG. So once that's generated those documentations, what we're going to do is clear the terminal, and we're going to run dbt docs serve. That's going to open that browser again with our documentation. And notice the source has appeared on the left-hand side. And if we look at the lineage here, you can see both of the sources are now part of this graph. And this one here called orders, that is referenced by the staging model, and we can now see that on the graph. And all sources are coloured green, so they very clearly stand out from our dbt models. So we're building up our dbt pipeline. It's very simple here, but you can imagine for a big organization, you might have hundreds or thousands of models performing all these data transformations and creating new tables in your warehouse. The benefit of dbt is that you have this easy way of working and defining models, and you can version control the code as well as the structure of the project being standardized, and that can help when onboarding other data engineers or developers. So it's very useful for transformations against data in your data warehouse. Now I want to finish this video with an example of some of the Jinja expressions that we can use in a dbt project. Now if we go to Snowflake, notice the orders table has this status field, and this has some discrete values. There's not a lot of different values in this. We have values like completed, returned, and shipped, and there's one here called placed as well. And let's say that for our monthly orders table here, what we want to do is instead of just getting a raw total, we want to get a total for each one of those statuses. Jinja can help with this, so let's go back to VS Code and go to monthlyorders.sql. Now we can set a variable for the context of this file, so what I'm going to do is set that at the top here, and I'm going to close the sidebar so we can see this. So we're setting a variable called statuses, and that's set to a list in Python that contains the values that are part of that column. So we have 5 values here. And then when we go down to our final common table expression, we're going to replace this line of code. We don't want to just count the orders themselves, but we want to do this for each status. Now we can create a Jinja for loop, so for status in statuses, and when you do this you need to end the for loop just below after your expression. And this is going to look familiar if you've used Django. It's similar to the Django templating language, and also of course Flask, which can use Jinja as well. And let's write the SQL expression here. So we're going to use a count statement, and we are going to use a case when within that count. So when the status is equal to the status that we have in our for loop, then we're going to return the order ID for the count function. And that's all we need to do here, so we can end that case when statement. So essentially for each status here, we're counting up the number of times that the status is equal to that status for each one of them. We can then alias the result, and I'm going to reference again the status field, and then after that we can add an underscore, and let's add the name count. So for example, for the first status here of placed, this is going to result in a column called placed count. And then we need to add a comma here for all iterations of the for loop except the last iteration. So we're going to add one final expression here. What we're going to do is a template if statement, and we're going to check if not loop.last. Now this is a special variable that's added by Jinja in a loop. You can check if it's the last iteration of that loop, and similarly you can also check other things such as is it the first iteration and so on. Now, as long as it's not the last iteration, we want to add the comma to separate the field from the following field, and then we can use end if here to close off the if statement. I hope that makes sense. We'll go over it one more time, but what I want to do now is just run the dbt run command, and let's see what this generates. So let's go back to the terminal, and it's dbt run, and this is going to change the final resulting table if I've not done anything wrong, and you can see it's completed successfully. So let's now go back to Snowflake and see what's been generated here for the monthly orders table. Now we've got the table here. If we refresh this, we're going to see that we have more columns in the table. So for each month, we now have a count for each one of the statuses. For example, if we look at the completed count, you can see 24 orders completed in January 2018, and there was 1 return pending and 4 orders returned. So now we have a month-by-month breakdown of each of these statuses, and what we've done with Jinja essentially is make the logic very simple to write. So instead of doing this for each field here, we've consolidated the logic into a Jinja for loop, and for each one of the statuses we're getting a count of when the rows equal to that status for the given month. And if you want to know what this actually does under the hood, let's bring back the sidebar, and what I'm going to do is go to the target directory here, which has a folder called compiled. And notice the monthly orders.sql file. I'm going to open that, and here we get the final compiled SQL. So when you compile your dbt model, it essentially replaces the Jinja syntax with valid SQL. So here you can see the count when the status is equal to placed, and we also have that for each of the other statuses. And notice that all of these count expressions have the comma separating them from the next one, except that final one here. And the reason that that was omitted, of course, is because of this statement here where we check if we're in the last iteration of the for loop, and we can exclude the comma in that case. So there's so many directions that we can go with this based on the data that we have already loaded into the database. For example, if we look at the orders table, we could join this ID here with what we have in the stripe schema that's also part of the source data set. So if we look at the payment table here, we can get a data preview, and notice we have an order ID, so we could perform that join. And we could then aggregate over fields such as the payment method or statuses, and we could get totals using the amount column. We could also find out which customers are placing the most orders, so we have that customer table as well, and so on. This has just been an introduction to dbt in this video. I hope it's made sense. And we've looked at some core features of dbt, such as models in this video. And these are SQL files that define transformations against some source data, and you can build up these files as a DAG. We also saw the concept of sources, such as this one here. This allows us to centralize the source tables that we already have in a data warehouse that have been loaded by external tools. We can then reference those sources and they get added to the DAG. We also saw the documentation features using the dbt-docs command. And finally, we've looked at some of the Jinja functionality, such as the source function, the ref function, and the ability to loop over data and create dynamic SQL statements. And you can imagine if you have complex workflows with hundreds or thousands of models, and these are all transforming data for your dashboards or your BI tools or perhaps even machine learning models, dbt can automate all of these transformations, and it can run on a schedule, for example at midnight every day, or in response to some kind of trigger. And this well-defined structure and the ability to source control all of this code is going to be a big benefit to large data engineering projects. And this is going to work with different adapters, so not only Snowflake, but you can use this also with Databricks, with Amazon Redshift, Postgres, DuckDB, and so on. So that's all for this intro to dbt. If you've enjoyed the video, check out our Ko-fi page. And if the video's been useful, give it a thumbs up and subscribe to the channel. And if you're interested in more dbt or data engineering videos, let me know in the comments, and we'll see you in the next video.